Hi, everybody. Welcome back to the Shikho Math Practice Lab, Learning Through Practicing. So this is the second part of the practice set number 5. And for the first part, we finished solving like 6 problems here. So we're going to complete this set to do the other 6 problems here. So in this practice set, we focus on the try to get familiar with the test of the divergences here. And then we also know if you have some differences or scalar multiplication of a convergent sequence, convergent series, so they will still be convergence, right? Then the last things here, we're going to talk about a special topic is how do I change the repeating decimals to fractions here. So those are the problems we are going to practice in this set. We already did all the way to problem F here. So we still have 6 problems left. And in these 6 problems, we're going to show like 2 special ways to solve some of them, special how to change the repeated decimal to fractions here. Okay, so like always, you should pause your video and try to solve all these problems by yourself first. And then after you solve it, then resume the video and come back here. We can check the answers against each other to see your answer is correct or not. Okay, so now is a good time if you want to pause your video and come back after you finish. And I'm going to the whiteboard now. Okay, so I guess I will see you soon. Oh, hi everybody. Welcome to the whiteboard. And so we are going to continue to solve our problems here. So we did our first 6. So for this part 2, we're going to start with the problem G's here. So the problem G's here is the problems like summations. We want to see this series summation n from 1 to infinity, and 1 over 1 plus 2/3 to the nth powers here, right? So we want to see this is the divergent or convergent series. So this is a very good review problem. I don't know you still remember we did what. So the first things I always said, you know, try to check divergence is very easy, right? So here the AN is equal to 1 over 1 plus 2/3 to the nth power, see here. So we say the divergent test is you let the n approach to infinity AN, right? So like in here, say the limit n approach to infinity, 1 over 1 plus 2/3 to the nth power. So what is this one here? This is a 2/3, right? It's less than 1. Then if you let the exponents become bigger and bigger, so what is this one going to approach to? This one going to approach to zeros, right? So your whole things here going to approach to what? 1 over 1 is equal to 1. So based on the divergent test, we know this is not equal to 0. If the limit AN approach, when n approach to infinity is not approach to 0, then we automatically know what happens here. This is what? This is a divergent series, right? And just try to remember, that's kind of the refresh your memory. Remember here, if the limit n approach to infinity, AN, goes to 0, can we say this is convergent or divergence here? So if it is go to 0, we can know, we cannot conclude, right? So this is the one a lot of students get confused. We know if it's not equal to 0, it's definitely is divergent. But if it's equal to 0, we cannot conclude. We might need to find a different way to test it. So this is just one of the review I just want to emphasize here because a lot of students, they always get confused by that, okay? So the G is pretty easy. Now let's take a look at H's here. H here, this is the summations. Okay, K is from 0 to infinity. Then this is the square root of the negative case here. Okay, so this one's here, we can set okay, so you can change this one, say this is summations, right? K is from 0 to infinity. Then this is 1 over square root of what? Case, right? Because you can move the negative 1 inside. And now if you plug in a few terms, K equal to 0 is 1. K equal to 1 is 1 over square root of 2. K equal to 2 is 1 over square root of the 2 to the square. K equal to 3 is 1 over square root of the 2 the third. So as you can see, from here to here, from here to here, they have a fixed ratios. Here is 1 over square root of the 2. So I know what type of the series this is. This is a geometric, right? Okay, so the R's here is 1 over square root of the 2. So the absolute R is less than 1. So what happens here? If a geometric series R is less than 1, we say what? We say this is a convergent or divergent. We say it's a convergent series, right? And what is the value it converges to? It converges to 1 over 1 minus R. So this is 1 over 1 minus what? 1 over square root of the 2. And then if you simplify this a little bit, it will give you the square root of the 2, square root of the 2 minus 1. So this is where the series will converge to here. Okay, so the other problems here. So the next problems here, this is H, so this is I. And the I's here, this is the summations, n from 1 to infinity, 1 over En, then plus 1 over n plus 1. Okay, so for these ones here, I want to, I will go ahead and divide it into two series here, right? So the first series here, this is a summation n from 1 to infinity, 1 over En. So if you plug the number there, so this is 1 over E, when n equal to 1, 1 over E to the what? Square, 1 over E to the what? Cube, and the right? So as you can see here, from here to here, what happened? They have a fixed ratio. So what is the ratios here? Is 1 over E. This is 1 over E. So I know my R is equal to what? It's 1 over E. Then the absolute value of R is less than 1. So I know this part, this one's here is what? It's a convergence, right? Because it's a geometric series. So what is the value it's convergent to? So in order to see that, we need to factor the 1 over E out. So this is 1 over E, 1 over E to the square, 1 over E to the cube, right? So my answers here will just be 1 over E, 1 minus R. So 1 minus 1 over E here, right? Okay, so this one's here, you can simplify it a little bit and it will turns out to be, I think it's 1 over E minus 1 here, okay? So I think you can simplify that. So these terms will simplify to that. Okay, so now the things I want to talk about is the second terms here, this term. Okay, so for these terms here, so I'm trying to find the n from 1 to infinity, 1 over n to the n plus 1. So how do I know this is a convergent, divergent? Obviously, this is not a geometric series, right? We're going to talk about these topics. We're going to, the next practice set, we're going to practice a lot of the skill I'm going to show you here. Here, I just want to give you a look ahead, and then we're going to practice a lot in the next set here. So in order to solve this one, I need to do the partial sum. So let's do the Sn. So the Sn is kind of from the k to 1 to n's, right? So this is 1 of the k plus 1. Right, so the partial sum, so I know if I let the limit n approach to infinity, Sn, if this limit exists, then I know this series exists. We practiced the partial sum in the previous the practice set. I hope that everybody still remember, right? So now in here, how do I break this, right? So in here, this is the special skill we're going to learn more in the next practice set. We call this a telescope. So these ones here, we can break it. It's kind of like a break it to this one is k plus 1. And so it's 1 over k minus 1 over k plus 1. So this is kind of like, I think you guys must learn this one in the partial fractions integrations, right? So you integrate your function into like a partial fractions. And this is what we call this a telescope, right? And like I said, we're going to have several practice problems in the next practice set to get you good at the telescope. But in here, we just use the technique. It's kind of look ahead to the next ones here. So like if when you put the k equal to 1, so this is 1 minus 1 minus 1 over 2. Okay, so when k equal to 2, so it's 1 over 2 minus 1 over 3. K equal to 3 is 1 over 3 minus 1 over 4. Then you do dot, 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 dot. When k equal to n, so it's 1 over n minus 1 over n plus 1 here. Right, so here, let's see here, make sure. So this is when k equal to 1, right? This is when k equal to 2. This is when k equal to 3, right? So this is when k equal to n, see here. Okay, now if you take a look, did you see something? You see here the boom, 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 boom. So like they always have a positive and negative, you can cancel all the way except last terms, right? So now you know your Sn is equal to 1 over n plus 1 minus 1 over n plus 1. This is what is your Sn. So now you let the limit n approach to infinity to the Sn is equal to limit n approach to infinity, 1 plus 1 minus, sorry here. Okay, so this is a 1 minus 1 over n plus n. And now you see here, when the n plus 1, n become very large, this is become very large, right? So the whole term become what? Become to 0. So that's why these terms here will become 1. So that's why you know the summation n from 1 to infinity, 1 over n plus 1 is equal to 1. So this is a convergence also, right? So that's why the whole things here, this is a summation n from 1 to infinity, 1 over en plus 1 over n plus 1. And this is a convergence because the sum of the two convergent series is a convergence, right? And it convergent to 1 over e minus 1 plus 1. All right. So like I said, if you have trouble with what the method I used here, and don't worry too much. And in my next practice set, we're going to drill these skills many, many times. Okay, so you will be good at it. Okay, so that's good. And that's what we finish this type of the problems here. Now the next part is how do we change to the repeat, the decimals to the fractions here. So let's take a look at part A's problem. All right, so if I have a 0.8, I repeat. Okay, so repeat a 0.8. So really, so everybody know this is just a 0.8, dot, 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 right? Okay, so now I'm going to show how do we do it, right? So let's take a look, right? So if you take a look, this one really, if I'm just going to break a few terms here, Okay, if you take a look at these terms here, the one I put in the pink, this is a 0.8, right? Okay, so now for these terms here, right? So the green one, maybe I color coding here, maybe give you a better idea. So here, this is a 0.8. Okay, now the green one is a what? It's a 0.08, right? So at the 0.8 plus 0.08, right? Okay, now let's take a look. The blue ones here, get a one more eighth here, right? So what is that? That will be point what? 008, correct? Now, if you do the one more, let me find the different colors here. So, okay, this one here, right? So this one here is what will be 0.0008, right? So now you continues here. Okay, so now I'm going to, so 0.8, right? I can change it to what? A to the 10th here. Now take a look at 0.08. So it's A under how much? Hundredths here, right? So the same thing is here. This is the 8 over 0.008. So it's over what? The thousandths here, right? Then here, this one here is 8 over what is 1, 2, 3, 4. 1, 2, 3, 4 is a 10,000ths here, right? So now, if I do a little change, then you will see this is A to the 10th. So what is a hundredth here? 10 to the square. So what is the thousandths here? 10 to the cube. What is 10,000 here? 10 to the fourth. Da, 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 da. So did you see a relations here? What is here? The ratio is what? 1 over 10. From here, ratio is 1 over 10. From here, ratio is 1 over 10. So you say, oh my gosh, this is the geometric series, right? With R equal to 1 over 10. And also, you know, the absolute value of R is less than 1. So what is here is a convergence, right? So you know this is a convergent geometric series. So now in order to use my formula, I need to factor the A over 10 out. Then you will have 1 plus 1 over 10 plus 1, 10 to the square, plus 1, 10 to the cube, right? Da, 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 da. So what is my answer? My answer, this is A over 10, 1 minus R. What is R? 1 over 10, right? So this is my R, right? So it's 1 minus R here. So this is my 10th here. So if you try to, so this will be A over 10, and this is 9 over 10. And your answer is A over 9 here. It's cool? Yeah, so that's how do you change that to a fractions here. Okay, let's take a look at the other one. Okay, so let's do part C first, and then we'll do the part B. I should have put a part B to the part C because the part B is a little harder than the part C. Okay, so let's do part C first, right? So this is a 4, 6 repeat. So that means this is a 4, 6, 4, 6, 4, 6, 4, 6, and da, da, da. Okay, so let's try the color coding here first. This is a 0.46, right? So this is equal to 0.46. Okay, now the next one here is this 46, right? So this is how many? Is a 0.0046. And now let's take a look at the other one. This 4 6s, right? So this is that, I think you'll be able to see the, so you should be able to see the pattern right now, right? So it's a da, 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 right? Okay, so now I can, okay, so now let's take a look, how do we put it, right? So the first 4 6, right? This is a 4 6 to the how many? Hundreds, right? And then plus this 4 6, how many zeros here? The 1, 2, 3, 4, correct? Okay, so it's a 1, 2, 3, 4. And then here it's a 1, 2, 3, 4, 5, 6. So it's a 46. It's 1, 2, 3, 4, 5, 6, and the da 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 da. Okay, so now let's change it. So this is a 46. This is 10 to the square. What is here? This is 10 to the how many power? 4th power. This is 46, 10 to the how many power? 6 powers, right? So did you see the relation? So what is the ratio here? R is equal to the 1 over 10 to the squares, right? 1 over 10 to the square. So R, the absolute value of R is 1 over 10 to the square is less than 1. So I know this is a convergence, right? So this is a convergence. So remember, in order to use 1 over 1 minus R, I need to factor this one, 46 over 10 to the square out first, all right? So then inside here, the first term become 1. The second term, after you factor the 46 of 10 square, what do you have? 10 square. Then this will be 1 over 10 to the what? 4th. Right, so the R is equal to 10 here. Now I can use the geometric series. So it's 46 over 100. So what is the ratio? 1 minus R. 1 minus what? Is 100th here, right? So now you know your answers here is 46 over 99 here, right? Okay, cool. Okay, so now I'm going to new pages here. Let's start the part B is here. Okay, so the part B, so this is 5.71358. So it's still the same things, right? So for this ones here, you can always just leave the 5. So let's write, you know, if you have trouble to see how many 0 you have, you can write out a few terms, right? 71358. So it's 71358 repeat, right? 71358. Okay, so this is a 5, just a whole number. You can just put it there. Okay, now let's take a let's color coding again. 71358. So this is a pointer 71358, right? Okay, now next one is here. Next one is here. Okay, let's see here. In order to get here, how many 0 you need to in the front? 5, right? 1, 2, 3, 4, 5. Then you have a 71358, right? Okay, and okay, so I accidentally, okay. Now let's take a look at this one, and this 71358. Let's see how many 0 I have, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 71358, right? Then the this is dots, right? Okay, so now the 5 will leave it by itself. So here, correct? Okay, so now this is how we write it. So this is 71358. How many 0? 5, right? So it's 10 to the 5th, right? So this is 71358. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 to the 10th powers, right? And then Then the next one, this is 71358. Oh boy, how many I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. So 10 to the 15. Then go . So, but it's the same idea. So what is my ratio R right now? It's 10 to the what? The 5th power, right? So it's 1 over 10 to the 5th power. So the absolute value of R is less than 1. So this series is a convergence, right? Okay. So in order to do use the geometric series, I factor things out. I still leave the 5s in the front, right? 71358, 10 to the 5th. And this is 1 plus. Okay, you factor 10 to the 5th out. What is the next terms you have? 10 to the 5th. What is the 15? What is this 15 terms you have? It's 1 over 10 to the 10th, right? Then Okay, so then I can, this is a 5 plus, then use a geometric series. So this is a 71358, 10 to the what? 5th powers, right? and 10 to the 5th power, and then you have 1 minus 1 over 10 to the 5th power here. Okay, and so if you simplify this a little bit, so these terms here, it will be simplified to what? Okay, so it will be 71358 over 99999. For some people, if you say, hey, I can factor some numbers here to make it a little bit lower, you can say this is 23786. Go to 33333. Okay, so what is your final answer? Don't forget, you still have this 5s, right? So it's a 5 plus 23786 plus 33333. Then find the common denominator and add it. I have here is 190,451,33333. Wow, that's kind of like a lot of those numbers, but we got it. So I think you got the same, you got the ideas, right? How to change the repeated decimals to fraction. So the first, I would recommend you write out a few terms. So you'll be able to see how it repeat, right? How many zeros you have. And then you use the geometrics, the series and the sum of the geometric series to find the sum. And that's it. So I'm so glad, you finished the practice number 5 here. And so don't forget practicing, and practicing. That's the key factor to make you good at math here. It's so nice to talk to you, and I hope to see you in the next practice set. We're going to put a lot of effort, try to practice the telescope and to see how do we determine the telescope series and how to find the sum there, okay? It is so nice to talk to you, and so you have a good day here. So I will talk to you in the next videos here. Okay, bye.